Hello grade 12s. Today I'm looking at question 2, the interpenetration curve of the 2015 final paper. The information that they give us is that we've got a circular pipe with a square duct, so the branch pipe coming in. They've got the auxiliary view of the square duct. We need to complete the front view showing the curve of interpenetration, show all the hidden detail, and the complete top view. Then the development of the square duct, so they want you to fold this open. Show construction. So there we have what we need to do. This line looks like it should be a center line, so long dash, short dash. So let's remember to put that in. For the positioning of the drawing, what I'm going to do is position the front and the top view very much on the left hand side of this drawing, so that I can have space to put in the branch pipe wherever I want to position it. I'm going to start with the top view, drawing the circle and then getting the branch pipe. Now what I'm going to do is actually skip a step here of drawing the auxiliary view at this stage. I'm going to just draw the auxiliary view down here or anywhere down on the side, just to get the measurements that I'm going to need. So what we need to do is we need to draw a square, and that has a length of 30. So I've projected an auxiliary view down here. I'm just going to show you a different method of transferring your measurements then across. I've projected up my length dimensions of the circle, and I marked off the height of 10 millimeters where it says it intersects at an angle of 45 degrees with our branch pipe. So I'm going to project our lowest point of the branch pipe up at my angle of 45 degrees. I'm going to go perpendicular to that, so angle of 135, and now I need to take these measurements across. So I've constructed my square over here, and what we can now do is I can take these measurements and just transfer them on that side. So in this auxiliary view, we obviously need the diagonal as the length of our branch pipe. So I'll just take the distance from each corner if you want, or you could take the distance of your center, because that you should mark off twice. So I'm going to mark that across now. There's my center point, and there's my other edge, and I can project those lines down now. So finding the length of the branch pipe, it says that from the center the distance out was 50. I've projected that up to where it intersects this middle line, and now project my line so that it is going to give me the edge of my branch pipe. So there is my front view. Now what I'm going to do is I'm going to mark off the width dimension that I need in the top view. Now if you remember, I've taken this distance to find that center point, so that is the distance that I need for the width dimension, and I'm going to come and mark that off on any vertical line in my top view. So So once again, the distance that I needed, that I used in my front view, is the same distance I'll use in the top view. Why? Because it is a square. So I like to mark and number my corners. So in my auxiliary view, I would have labeled the 4 corners. Then I project those lines down. It would give me the following points in the front view. Now we just need to imagine that if we rotated this shape to being vertical, as we would turn this down to get it to the original shape, 1, 2, 3 and 4, so that when we get into the top view, the following would happen. Okay, 1 and 0.3 are the center points, 2 and 4 are the side edges, and then follow those lines down to where they will cut in the top view. So 1 needs to go to line 1, 2 and 4 we've got already, and 3 would be back in the center again. And let me just project this down so you can see that. And then we can join up the corners of the branch pipe in the top view. We've got a circle here and we need to put in the center lines. So there we have the completed top view, my circle, the main pipe with the center lines. The branch pipe, our square duct. Just please remember this is open, but because there's a bend in the duct here, that's why we would have this line in dark. Why? Because when we look down at it from the top, we'll see this bend on the inside of this hole. Okay, so that's why this line would be straight going all the way across. Next, we're going to find where that curve of interpenetration is in the front view. Now, what is very important to remember about your curve of interpenetration? If you have got shapes that have got straight sides, the lines joining the curves of interpenetration will be straight lines. As soon as you've got a circle, either as the main pipe or as the branch pipe, the curve will be curved. So in this case, we've got a circle. So where we have the square duct going in, we're going to have a curve joining up those points. Now, our problem is that we have only got 4 points to get the shape, which isn't very accurate. So we need to put in more shapes or more points to find where the square duct is going to hit our circle. So we've got a circle here, and what do we usually do with a circle? We know that we need to divide it up into our pizza slices. Now, some of those pizza slices aren't going to hit here, but we can certainly get the ones on this side. So that's going to be my next step, is putting in the pizza slices. So if we look at the points that we've got at the moment, this 30-degree doesn't cut here, so we're not going to be able to use it. We've got the horizontal, the 30, 60, and our lowest point. So we're now going to take these points up. So let's find the 4 points of our square duct first, and then we'll worry about finding these other edges. Now the process needs to be the same as before. We need to follow the theory of 2 points. So from our top view, we're going to project vertically, and we're going to have our branch pipe coming in at our 45-degree angle. So let's find the points. So this point was 0.4, this point was 0.2. So 0.4 gets cut on the edge, which means this point here is going to give us 0.4 already. Next, at the top and the bottom, so at 0.1 and 3, it's going to hit at this specific point. So I need to project 0.1 to cut at the top of the shape. There was 1. And 0.3 is at the bottom of the shape. Point 2. Now let's remember 0.2, if this is the edge of my circle, 0.2 is behind that edge. It's going to mean that that is going to be hidden detail. Now the advantage of having a branch pipe that is at an angle is that we can use that to help us get these remaining points. So how do we do that? I'm going to label these points A, B, and C, and now I'm going to take my A line to where it cuts the branch pipe. Where it cuts the branch pipe, it's going to give me the A, but let's call this A at the top and A at the bottom of the shape. So if I project T up to cut the branch pipe, that gives me point T. This is going to give me point B. Now, if we use this as the theory of 2 points, what I'm going to do now is project point B and T down parallel to my branch pipe. Now I take where A is on the circle and I project them up, and that gives me point T and point B. Okay, so just recap that. Where our 60-degree pizza slice cuts, we project that to take the branch, hit the branch pipe. Where it hits the branch pipe, we project it up to hit the branch pipe in the front view. Then we project down parallel to the edge of our branch pipe, and then from our point we project up the points to find where they cut. So that process works when we've got the branch pipe that is at an angle to the main pipe. You're not able to do that if the branch pipe was parallel to the base of the front view. So let's move on. So my next point is point B. I'm going to project point B up. So here's my B line. I'm going to project my point B line to hit my branch pipe. And I'm going to call it B1 and B2. So where B1 hits the branch pipe, project it up to hit the branch pipe in my front view. Where B2 hits, I'm going to project that up and get me point B2. Now project it down parallel to the branch pipe until it hits the B line. That's where it hits the B line. Giving me point 1 and 2. the next point we're going to do is our turning point at C. So before I'm going to go on to point C, I'm actually going to just go over the points that I can see here. Okay, because our highest point of the branch pipe we've already calculated. So what I'm actually going to do is just join up my points at the moment. So there's my highest point. There was B1. Here was T4, the B, and my B2 to 3. So it looks like this little punctured shape that we're going to get for our curve of interpenetration. So there is the curve. So that's showing from where it's touching at the edge here to the highest point of our duct. Now, because that's the highest point, going to point C is going to be in hidden detail. So we now need to find where point C is, and that is slightly below the highest and lowest point of the square duct. So it's the same process that we've used before. So I'm projecting where point C cuts our branch pipe. So let's go C1 and C2. Now, same process as before. We're going to project where C goes up here, which we've done already. Now let's take point C1. That's where C1 hits our branch pipe in the front view. This process we can only use if the branch pipe is at an angle. Project them down, so that's where C cuts, and there is C, and project C2 to where it cuts the vertical line, the theory of 2 points. So here is the lowest edge coming to C and coming to C from point 1. That would be hidden detail that's behind the shape. Now if you remember, we've already found point 2. Here is point 2 over here. So that's going to give us what we need in hidden detail now. So if we take point 1, this little piece curves here, very small little curve to hit our point C1. C1 curves out slightly now to hit at point 2, curves again back to our C2 point and finishes coming down to point 3. So if we finish off that shape, this little edge would be hidden detail. So where it touches the edge of the shape, a little straight vertical hidden detail line up to where it touches there, and a permanent line there. And now just to finish off the last few lines in an outline. So there we have the completed front view showing our curve of interpenetration and the hidden detail coming around there. So just remember, very tiny little vertical hidden detail showing the edge of the circle to where it was cut by the square duct. Here is point 2 on our square duct. Here's where it cuts at the lowest point, and there's where point 3 hits the circle back there. So from here we need to do the development. What we would have to just understand about the example here is that because they don't have as many points in this shape. That's why they can add more marks in and make you do the development. So they've asked you to develop the branch pipe, and generally the best way to do that is if you could project parallel to